Hello students. Today's topic, the coordinates of x relative to the basis v. Suppose we are taking one basis for a vector space v and take one vector from this vector space, and this is a vector belongs to vector space in the sense this can be expressed as linear combination of all basis vectors b1 to bn. So for that we are taking some scalars. How many number of vectors here? N vectors. So we should take n number of scalars c1 to cn. Then these vectors taken as a column, which is nothing but the coordinates of x relative to the basis b. This is denoted by x over the basis b, whose elements are c1 to cn. So it is nothing but the scalar set which is taken as a vector. Now see here, take one basis. Here is one basis b1, b2 whose vectors are given. R2 is a vector space here. Then as the coordinate vectors x over b is given, then find the value of vector x. So here x over b is given in the sense it is the set of all scalars, right? So R2 is a vector space, b1, b2 is a basis that is given, and x over b is nothing but scalars. How many vectors we have? 2. So 2 scalars we should take c1, c2, which is given by -2 and 3. And we need to find the vector in vector space R2. So any vector which is belongs to R2, then we must take a linear combination of vectors in the basis b1, b2. So x can be written as c1, b1 plus c2, b2. And substitute c1 here, c2 here, b1, b2. Then -2, 0, and 3, 6 here. -2 plus 3 is 1, 0 plus 6. So any vector in R2 is 1, 6 in R2. Similarly, if x is given and basis is given, we need to find coordinates of x relative to the standard basis. Here what we need to show that the entries in the vector are the coordinates of x relative to the standard basis e1, e2. That means these are the entries in x, and x over b is also same as 1 comma 6 when it is if the basis is standard basis. So let us see, R2 is a vector space and x is any vector in R2. Then that vector is x over b we need to find, take as 2 scalars because here 2 vectors are given. That's why c1, c2 is nothing but x over b. Then x belongs to R2 means there exists 2 scalars c1, c2 such that we have the formula c1, e1 plus c2, e2. Then this is 1, 6 and c1 into e1 plus c2 into e2. After solving this, c1 plus 0 equal to 1, that is c1 equal to 1 and c2 equal to 6. So x over b, the coordinates of x relative to the basis b is also equal to 1 and 6, which is coincide to vector when the basis will be the standard basis, hence proved. Similarly, we have two vectors which are from basis and x is given, vector in R2 is given, and we need to find coordinate vectors of x relative to the basis b. Obviously what we are taking x over b, c1, c2, because here it is in R2, that's why. So x belongs to R2, then there exists scalar c1, c2 such that we can write as linear combination. Then x equal to c1 into b1 plus c2 into b2. Then we are taking as equation form like 2c1 plus minus of c2 equal to 4 and c1 plus c2 equal to 5. By solving these two equations, we are getting c1, c2 and substitute c1, c2 in x over b. Then we are getting the vector as 3, 2. So here also v1, v2, two vectors in a basis are given, and x is a vector in these having 3 elements means it is belongs to R3, where b is a basis for h and h is span of R1, v1, v2. Then determine if x is in h, then find the coordinate vector related to the basis b it is asking. So coordinate of x related to the basis b in the sense x over b we need to find out. For that, how many numbers we are taking means how many vectors it is given, v1, v2, 2 vectors are given. So we should take only 2 scalars c1, c2, take as x over b, and we need to find c1, c2 values. For that, x is any vector in R3 that is given here, where R3 is a vector space, then x is spanned by these 2 vectors in the sense we must take 2 scalars such that x can be written as c1 v1 plus c2 v2, which is the linear combination. Now substitute x value here, c1 into v1 plus c2 into v2. Then 3c1 minus c2 equal to 3, 6c1 plus 0 equal to 12, 2c1 plus c2 equal to 7. By solving any two equations from these three, we are getting C1 and C2 values, which is nothing but x over b. Similarly, we have basis is given here. Here x over b is given in the sense scalar numbers are given. C1, C2 are 5 and 3, and we need to find out the vector in R2 or R3. R2 simply because we have 3 entries for every vector. That's why R2 is a vector space here. And similarly, X is a linear combination of two vectors b1, b2. Then substitute all those values. Then X we need to find out. C1, C2 are also given 5 and 3. Substitute here. Simply here 15 minus 12. Here minus 25 plus 18, which is the required vector which is in R2. Here is one similar problem. Find the vector x determined by the given x over b, where x over b, that is scalar vector is given, scalar set is given, c1 is minus 2, c2 is 5 here, and two basis vectors are given. Then we need to find any vector in R2, means that vector can be expressed as linear combination of these two vectors. Then substitute those values, then you are getting x vector which is belongs to the given vector space R2. Similarly here x over b is given and b is a vector. So according to the entries we need to find the vector space. Here in one vector we have 3 entries. That's why R3 is a vector space here. And here we have 3 vectors, means we should take 3 scalars. What are the scalars here? 1, 0, minus 2, c1, c2, c3. And we need to find x which is belongs to R3, that we need to find out. So here this is b1, b2, b3. And x over b is given here, and x belongs to R3 in the sense x can be expressed as c1 b1 plus c2 b2 plus c3 b3, and substitute all those values. So here substitute all those values, simply we are getting the x vector which is belongs to R3. Similarly here is one problem, b1 b2 b3, same x over b is given, means c1 c2 c3 are given. Then x we need to find out from R3 because each vector has same entries, 3 entries. So x belongs to R3, then x can be expressed as these vectors, then substitute, then you are getting the answer. Yes, this vector belongs to R3. Similarly, two vectors are given here. X which is belongs to R2 is given, and find the coordinates of x relative to the basis b, means x over b we need to find out. So x over b, obviously it is a set of scalars. So how many vectors it is given? 2 vectors. So 2 scalars we should take and substitute those values. X equal to c1 b1 plus c2 b2. X is given here, substitute here c1 c2 we need to find out. Then by taking the equation c1 plus 2c2 equal to minus 1, minus 4c1 plus minus c3c2 equal to minus 6. After solving this, we are getting c1 c2 values, which is nothing but x over b. That is, coordinates of x related to the basis is 3 minus 2. So see here, 3 vectors are given from basis, and x is a vector from R3, that is vector space that is given, and h is spanned by these 3 vectors. Then what we need to find? Find the coordinates vector x relative to the basis b, in the sense x over b we need to find out. So for that, how to consider the vectors elements? Yes, here 3 vectors are given, means we should take 3 scalars c1, c2, c3, right? Then there exists c1, c2, c3 such that x can be expressed as linear combination of all these, that is c1 b1 plus c2 b2 plus c3 b3. Then substitute those values here equal to x here. Of course, we can do in 2 methods, that is by taking this c1 minus 3c2 plus 2c3 equal to 8, like this we are getting 3 equations. By solving that 3 equations, we are getting c1, c2, c3 values, of course. But another way to solve this problem is take this as first column, second column, third column, and right side values. Now we are doing the row operations, that we need to convert this matrix, this left matrix, into identity matrix. Then whatever the right side entries are nothing but the x over b matrix. Like let us see here. See, what are the possibilities to make it into 0 here? Minus 1 here, 1. So comparing to R1, R2 plus R1, then it will be 0, right? So R2 implies R2 plus R1. Here also 3 is there, right? Minus 3. So minus 3 means R3 plus 3 into R1, then it will be 0 here. So take R1 as it is. R2 means R2 plus R1. R2 plus R1, 0. 4 minus 3, 1. Minus 2 plus 2, 0. Minus 9 plus 8, minus 1. Similarly, R3 plus 3R1. R3 plus 3 into means 3 minus 3, 0 here. R3 plus 3 into this is minus 9. 9 minus 9, 0. 4 minus, 3 2s are 6. 6 plus 4, 10 here. Similarly, we can do for the next one. Now, R3 implies R3 by 10 here, then it will be 1, it will be 3. Now, here 0, 1, 0, 0, 0, 1. Here 1, 0, 0 we want. So, make this into 0 by using this value. So, simply what we can say, R1 implies R1 plus 3 into R2. R1 plus 3 into R2. Let us see. Then change R1 by using that operation, then it will be 0. Now we want this as 0, right? So this as 0 by using 1. So R1 implies R1 minus 2 into R3, then it will become 0. So R1 minus 2 into 0 is 1. So 1 as it is. 0 minus anything is 0. 2 minus 2, 0 here. 5 minus 2 into this, minus 6 plus 5 is minus 1. Now it will become into identity matrix here. Then whatever the right side vector, which is nothing but the x relative to the basis B matrix, that is x over B matrix. So what is x over B here? Minus 1, minus 1, 3 is the required answer. Similarly, we can see this problem. 3 vectors are given here. X is given and h is spanned by these 3 vectors. Then find the coordinates of x relative to the basis B, in the sense x over B we need to find out. Here 3 vectors are given, means 3 scalars we should take, and take the linear combination as it is. Now make it as first column, second column, third column, here right side. Now we are converting this total in terms of 1 0 0 0 1 0 0 0 1, right? Now here make this as 0, R2 minus R1 here, and make this as 0, R3 minus 3 into R1. So this is 0, and 8 minus 6 means 2 here. Here 3 minus 3 is 0 here. Like this we are converting the R3 row. Now see here, 0 1 0 form it is. Simply we can take as what? This divided by 2 means here 1, here minus 1, right? Here 1, here minus 1. Now 0 1 0 should be in the second row. So we are interchanging the rows R2 and R3. Then R2 to R3, R3 to R2. Like this. Then we need to convert this as 0 by taking what? See here, this as 0, that means R1 minus 2R2. R1 minus 2R2, then it will become into 0. R1 minus 2R2, R1 minus 2R2 means here 1, here 0, 1. R1 minus of minus plus 2 here. So here plus 2. Now here 1 0 0 we want here. So R1 plus R3, then it will become into 0. R1 plus R3, R1 plus R3. Then this is 2 0 0 like this. Now here R1 by 2. By 2 means here 1 will come. Here 1 0 0 0 1 0 0 0 1 we want, right? So for that, to make this into 0, R3 minus R1. R3 minus R1 means this will become into 0. Now here minus 1 is there, plus 1 we want. So divided by minus 1 here, then it will become 1 1. Then this is the identity matrix. Then what is the right side matrix, which is nothing but what? Right side vector is nothing but x over B vector. See here one more important problem. Same basis is given and vector is given. We need to find out coordinate vectors over B. But here basis in terms of polynomial is given, not in vector form, not in matrix form. Here polynomial vector basis is given, and one polynomial is given here. The coordinate vector of P of t, that is vector x instead of x, P of t is given. X over B we need to find out, that is P of t over B we need to find out, right? So here what is the degree here? It is of highest degree is 2. That's why P2 is a vector space here. And in the polynomial, remember, always degree is 2 means it should have 3 terms. Because in the polynomial, constant term, t square term should be there. So P2 is a vector space and basis is given here. And one vector in polynomial is given, right? A0 plus A1t plus A2t square. And P of t belongs to this P2 that is given. One vector is given. And what we need to find is x over B, but instead of x here P of t is given. So P of t over B we need to find out how many vectors it is given. 1 2 3 vectors are given. So 3 scalars we should take, and P of t can be expressed as C1 into first vector plus C2 into second vector plus C3 into third vector. Now see here P of t equal to like this, and multiply each and every term here and compare constants here. C1 here, where is the constant? C plus C3, and t terms, what are the t terms? C2 plus 2C3 here, and t square term C1 plus C2 plus C3 into t square. Take the left side as it is and compare the constants. Then C1 plus C2 equal to 1. Compare t terms means this equal to 4, and compare t square terms means this is equal to 7. Now converting into matrix form by taking the coefficients of C1, C2, C3. What are the coefficients of C1 here? 1 here. Here there is no C1, so 0. Here 1. Similarly C2 is not there, 0. C2 is 1 here, and C2 is 1. C3 1, 2, 1, and right side value. Now it should be taken converting into identity matrix. So here 1, 0. See here R3 implies R3 minus R1. R3 minus R1 means it will become into 0. R3 minus R1, 1 here, 1 minus 1, 0, 7 minus 1, 6. Now interchange these two because 0, 1, 0 is there. So interchange R2 and R3, then it will become like this. Now R3 implies R3 minus R2. Then it will become 0. R3 minus R2, 0. 2 minus 0, 2. 4 minus 6 minus 2. Now here this divided by 2 means here 1, here minus 1, remaining terms as it is. Now here we want this make it into 0, right? By using which number? This number. So R1 implies R1 minus R3 here. So it will become 0. It is 1, 0, 0, 1 minus of minus plus 1, that is 2. Now it is identity matrix, and remaining is the X over B matrix. Here P of t over B. This is P of t over B matrix. Vector is nothing but the scalar set, that is 2, 6, minus 1. Similarly, one more similar problem. One vector in polynomial is given and P of t is given. We need to find out P of t over B. Let us consider as C1, C2, C3 because 3 vectors are given here, and take the linear combination like P of t equal to C1 into first vector, C2 into second vector plus C3 into third vector. Now multiply every term and take the constant C1 plus 2C3 here, t common, C2 minus C3 here, and t square common, minus C1 minus C2 and plus C3 here, right? So minus taken as common, then it will be like this. Then compare the constants, this equal to 1, and t terms and t square terms here. Then make it into matrix form. We can take as columns as rows or rows. So C1 1, C2 0 here, 2 and 1 here. Similarly C1 is 0, 1, minus 1, 3. Like this we are considering, and make this into 0 by taking R3 implies R3 plus R1, R3 plus R1, R3 plus R1, then we are getting this one. Now R3 implies R3 plus R2, then it will become into 0, right? R3 plus R2 means here 2, and R3 plus R2 means minus 2. Now it will become into 1 by taking by 2, then it will be 1 minus 1. Now here make this term into 0 by taking R2 plus R3. R2 implies R2 plus R3. Then this will become 0. This will as it is. This will plus means here 2. Again this will converting into 0 by using this means R1 implies R1 minus 2R3. Then R1 minus 2R3 means 1, 0, 0 here. R1 minus of minus plus 2 means 3 here. Then which is identity matrix and which is the required X over B vector.